All right, guys, this video is to reinforce or remind us on some of our concepts for our learning activity one. This is important because this will be a feed into future activities we're going to be doing, such as building the plan. So what we said we want to do here is start by ideating some problem domain, right? Come up with some business problem you want to build the enterprise application for. So once you have a domain problem, you're then going to build user stories around it, right? You're going to gather as if you were interviewing your user. From user stories, you're going to apply lexical analysis and create your requirements document. And it should be formulated as a series of numbered requirements, R1, R2, R3, and so on. And requirements in Agile are always specified in the formulation of the system shall. The system shall do this. The system shall provide the college administrator with a panel to enroll students and so on. So now you've written your requirements. You then do lexical analysis. You look for actors with goals and you figure out, you make up, you basically invent or think about what needs to be the business process to make that goal happen. You now have use cases. From use cases, you generate UML. UML is a series of boxes on the screen ultimately, and each box or UML entity designates or is named by a business process that it delivers. Within that UML business entity, you write data and behaviors that business process is going to be in charge of. And now you remember your solid programming principles. So you think according to the knowledge principle, which UML entity or which business process knows the most about a certain piece of solving the business domain problem. And to that UML entity, you give your data attributes, or you assign the data attributes and the methods or behaviors, right? So solid says we want high cohesion, low coupling. And a good way to attain that is by keeping behaviors and data as close as possible to the object which is in charge of delivering them. Now, of course, you need to scatter behaviors among numerous classes, so you're still going to need to do method calls between classes, and you're still going to need to use shared field composition. But the UML diagram lets you pre-plan before you start writing code. It informs your thinking as to what's probably the most logical place to park the data attributes and the behaviors. Because when you did your business domain analysis, you made a catalog of all of the data points and all of the behaviors that your use cases need to deliver. So now you use the knowledge principle, appropriate assignment of responsibility, and you think which UML entities would be the most reasonable or kind of the best ones to insert, to house those data points and those behaviors into. Now, this is an art, it's not a science, and if you put 3 developers in a room, they might have 9 different ideas. Your skill, your judgment is what your employers are going to be paying you for. And there's also the concept of iterative design or round-trip engineering, which means that as you're developing it, maybe with a team, it's expected you're probably going to change your ideas on what's the best way to do it as you get more experience working with your system. Anyway, after you have your use cases as good as you can make them, and by the way, remember what Agile says. We don't want to fall into the software engineering crisis again. We don't want a 5-year deployment time frame. So Agile says do not try to do a perfect job. Agile says do something that you can ship out today. Agile factors in the project management, right? Because we said that unified process is the fusion together of software engineering and project management. And Agile says you do the best job you can do today and ship it out. It is better to send out a poor product today than a perfect product 5 years from now, because 5 years from now, whatever you're doing is going to be irrelevant anyway. So an Agile sprint, in Agile software development methodology, you do the best job you can today, you send it out, and then let your users feedback on it, and you can iteratively improve it and make it better later. Anyway, that's how we avoid letting the software crisis happen again, by shipping product every single day and getting it into the hands of customers and testers. Now, once you have your UML in a real sort of proper delivery of unified process, you would now forward generate your UML to Java classes, one class per UML entity, and UML knows about data and behaviors. So obviously, data in UML entity becomes data fields in the Java class, and methods or intentions in your UML become methods in your, or behaviors or intentions in UML become methods in Java. Later on, we'll see how to use object interaction diagrams so we can plan the connection of our methods. We're going to learn how to use the method choreography or object interaction diagram of UML so we can plan and optimize how our objects communicate via method calls. Maybe that'll be learning activity 3 or something. But for learning activity 1, I do expect you to use the structural UML diagram, which is what lets you plan the placement of data fields within your classes so you can use shared field communication between your Java classes as a way of communicating information. So anyway, normally once you get your UML, you generate it to Java, but just for the sake of learning activity 1, you're going to forward generate your UML to the traceability matrix. So you can use an Excel spreadsheet or a Google Sheet. That would be a good way to do it. You write your requirements that you gathered in stage 2, right? Stage 1 was ideating your problem domain. Stage 2 was writing requirements documents. Stage 3 was making use cases. So for the traceability matrix, you're going to write your requirements, R1, R2, R3, R4. And then across the top row, you're going to write your classes and methods. And then you're going to put a checkbox wherever a requirement meets a method which implements it. And then you're going to start to think, and you don't have to do a perfect job for learning activity 1, but you should at least start to be aware and to think about the fact that where a method meets a requirement, you need to put a test oracle, right? You need to put a test case with some test data. And once we've all gotten that done, I will then show you how we go from our traceability matrix to Java code. That is learning activity 1.